Good evening, this is Dr. Pradhan here. Welcome to NPTEL project on econometric modeling. So, today we will discuss cointegration technique. That is one of the interesting technique under time series modeling. So, in the last lectures we have highlighted the basic framework of unit root problem, because without knowing unit root or ternary tissue, you cannot start cointegrations. Okay. So, unit root you must know the nature of the variable first, that accordingly you have to apply the cointegrations. Okay. So, first I will briefly highlight what is exactly unity root problems, then we will come down to cointegrations. Then also we will discuss the in the same times the causality issue. So, now what is first of all the unity root problems? The unity root problem objective is to know the order of integrations where the variable will be ternary in nature. Is it order of 0, is it order of 1 or is it order of 2 or so on. So, that the variables can be get to know whether it is ternary in nature or non ternary in nature. So, depending upon the order of integration where the variables are ternary in nature, we can apply the cointegration and causality technique. So, without knowing the unit root problems or the ternary tissue, it is very difficult or it is not possible to enter to the cointegrations and causality test. Okay. So, as I have mentioned in the last lectures, there are many techniques available to check the ternarity problem. So, that two unit root problems. So, we start with the Dickey test, then we discuss with augmented Dickey test, KPSS, Phillips-Perron test, NG test, and so many things are there. So, basically in the last lecture we have highlighted the concept of Dickey test and augmented Dickey test. So, I just briefly bring that these two techniques little bit, then we will enter to the cointegration techniques. So, Dickey test, the standard form of Dickey test is delta y t equal to alpha 0 plus gamma y t minus 1 plus u t. Okay. So, here alpha is need to be significant. Okay. If alpha is significant, then the variable is ternarity, attains ternarity, or it does not attain the ternary. So, this is standard Dickey test. So, corresponding to Dickey test, the augmented Dickey test statistic will be written like this: delta y t equal to beta 0 plus beta 1 y t minus 1 plus summation, you can say lambda I delta y t minus I plus u t I equal to 1 to n. Okay. So, this is the standard tricks of this is a ADP test equation, this is Dickey test equations. Okay. So, by the way, there are three forms of mathematical equation are available with Dickey test and augmented Dickey test. So, we start with the delta y t equal to lambda y t minus 1 plus u t, then this is the starting point, means if we remove this one, then the starting point is this and this. Okay. So, then this is the starting point, and with respect to this particular model, so we can add drift component, we can add trend component, and we can add both the components. Okay. So, I am not highlighting all these details here, because we have already discussed all these issues in the last lectures. So, here if you will get the means in this particular equation augmented Dickey equations, because it is more advanced than Dickey a simple Dickey test. So, beta 1 is the important parameters. By the way, beta 1 should be statistically significant to know the stationarity levels, okay, or order of integration through which you can say the variable is stationary in nature. Okay. Suppose this is integrated, this is beta 1 here alpha 0. So, means null hypothesis that beta 1 should equal to 0 against beta 1 beta 1 not equal to 0. So, that means beta 1 needs to be significant, okay. Beta 1 needs to be significant. If it is significant, then we will call it is integrated of order 1 here, okay, integrated order 1s. Suppose it is not stationary at these levels, then you go for second difference, okay. It is called as a del square yt, okay, double means we can write like this here del yt or delta y square delta square yt, which is equal to lambda I delta yt minus I, okay, plus summation lambda I, okay, its lambda is already there here. So, then you put it here, this is alpha I y t minus I, of course, delta is there. It's once again I am writing here delta y t equal to alpha I delta y t minus I, okay, plus lambda I delta squares y t minus I equal to 1 to n plus b t. Okay. Now, again this is very important here, okay, lambda in fact this is this particular item should be statistically significant, okay, this should be statistically significant, okay. So, depending upon the significance levels, so we can check whether the variable is stationary in nature or non stationary in nature. So, that means first you start with the simple augmented Dickey polar test, then you see whether the variable is stationary attains stationary or not. Okay. So, now your objective is to know at what level the variable will stationary, is it at the level data, is it at the first difference, is it at the second difference, is it at the kth difference. If it is the if it is stationary at the level data, then it is integrated of order 0. Okay. If it is attains stationarity at the first difference level, then you call it say it is order of integration is 1. Similarly, if it is attains stationary at the kth or kth difference levels, then you can say that it is integrated of order k. So, that is an requirement, one of the most important requirement for cointegration technique. Okay. Until unless you know the stationarity issue, then you cannot move into the cointegration technique. So, now you come down to the cointegration structure. So, what is all together the cointegrations? You see, the basic definition of cointegration is that. So, we like to know what is the long run association between variables. Okay. So, long run association between variables. You remember one thing very carefully, in the time series modeling, your sample size should be very high. Okay. Otherwise, it is very difficult to handle time series models where the lag is in the with you. Okay. So, once you are using lag, then obviously, the sample size should be substantially high. Okay. The moment sample size is substantially high, then it is the question of long run analysis. Okay. So, when there is a long run analysis and when you are handling more variables at a time, then you know what we have discussed in the case of simultaneous equation modeling and structural equation modeling. So, in a particular system, once number of variables are very high or large in numbers, then obviously there may be question of interdependence. Okay. So, the question existence of interdependence in the time series setting is called as a cointegration. So, we like to know what is the long run association between these two variables, is there, are they convergent or are they divergent. Okay. So, that means the cointegration will come into the picture. So, cointegration represents the existence of long run equilibrium relationship between two or more variables. So, let us we start with the two variables at a time. That means, cointegration technique is a multivariate technique. So, with one variable co-integration cannot be possible. So, we start with the at least two variables like correlation or regressions. So, co-integration also starts with the you can say two variables together. So, okay. So, it is not like that like in the time series modeling. So, we have yt minus 1, yt minus 2. So, with one that is univariate time series modeling. With single variables you will create additional variables. So, that is not the structure of co-integration. In the co-integration textures there should be two different variables, or let us say yt and xt like this. So, yt and xt. So, we need to create here yt minus 1, so yt minus 2, that is one structures continue, then it is xt minus 1, xt minus 2, xt minus 2, it will continue. So, this is one type of situations. If this game boundary is this sides, then it is called as a univariate time series modeling, and this is called as a univariate time series modeling. But when we will integrate these two, this is called as a multivariate time series modeling. So, now there are lots of techniques under multivariate time series modeling. So, one is called as a co-integrations. So, another is called as a causality, that is the causality. Okay. So, our main today's discussion is with respect to this co-integrations and causality. So, what is all about the co-integration, how to detect it, and why it is there and what is its relevance, then we will come down to causality. Okay, so, co-integration is the middle way of this time series setting. So, the initial setup is unity root, then end setup is causality, in between co-integration will play a middle role. Okay. So, it is just like a middle order batsman. So, now we have to see how co-integration will give you signal for the causality. So, it will give you means it will indicate that there is a long run association between these two variables. That means, if there is a co-integration, of course, by definition we can say that there is a association between these two variables, that too in the long runs. And if it will give you only the long run association between these two variables, but it will not give you the indication of direction of causality, where because time series modeling, one of the major objective is to detect the direction of causality, which is a special feature of time series modeling, which is not available in the case of cross sectional setting, where the causality is one way. Here we have two-way causality, there is a possibility of two-way causality. So, that is why, because it is all about time series setting. So, we first know what is the co-integration funda. Okay. So, co-integration means the existence of long run equilibrium relationship between two or more time series variables. Okay. So, that is very important, time series variables. Okay. So, now like unit root techniques are many techniques are there, co-integration techniques, co-integration techniques, like unity root co-integration techniques are also multiple in natures, but there are two standard forms of co-integration technique. One is called as a easy technique, and another is called as a JJ technique. Okay. So, this is called as a Engel-Granger co-integration technique, and this is called as a Johansson and Giselius co-integration technique. Okay. This is much simpler, easy to understand, easy to calculate. This is too complex, difficult to calculate, and is too much time taking. Okay. It is very easy to handle, this cannot be easy to handle. Okay. With means easy to handle means it is manually, it is very easy to, it is not so easy to handle when the setup is very complicated, but it is more advanced, more accurate, more reliable, and more useful in fact. So, we start with the process of easy technique, then we will converge to Johansson technique. Okay. So, Johansson technique, generally when you will use softwares, it is better to use Johansson techniques rather than easy test. Okay. And the problem, if just like in the optimization problem we have graphic techniques and algebraic techniques. So, here also same things. So, if the variable problem setup is with respect to 2 variable only, then simply you can apply the Engel-Granger test. In fact, it can be also Johnson Granger test. In fact, you can also apply Johnson-Zislewski test, but Engel and Granger's test is very much useful for the 2 variable setting. So, what is the test procedure here? The one of the condition for this test is that there must be 2 variables x t and y t. Okay. This this Engel and Granger's they have defined the possibility of convergence between these two. So, that convergence is called as a cointegration. So, they are very they got Nobel Prize for this particular techniques, and they are very intelligent, and basically they are statistician. They have developed a very beautiful setting in the time series problems to know the existence of long run equilibrium relationship between 2 variables. Okay. So, basically it has a 3 standard steps. Okay. First step is, let us say there are 2 variables x t and y t. So, now if you have x t and y t, so then obviously, so you like to know is there any relationship between x and y t. So, that is our target. Obviously, you have to first find out the tesonarity issue here, you also find out the tesonarity issue here. Okay. So, this is your first job. So, once you have the tesonarity issue, then come down to existence of cointegration. So, it will give you, once you know the order of integration, it will give you signal how you have to handle the cointegration technique. Okay. So, that means it will give you a signal that there may be possibility of long run equilibrium. So, but it will not give you positive signal that there is a long run relationship. So, for that you have to apply the cointegration technique. So, this easy test basically give you means it consists of 3 steps altogether. So, first step is 2 variables must be integrated of same orders. Okay. So, 2 variables must be integrated of same order. Okay. Preferably like this x t integrated of order 1 and y t integrated of order 1. Okay. So, this is the first condition of the cointegration technique, for that too easy under easy test. So, 2 variables must be integrated of same orders. Okay. So, let us assume that that means they are tesonary at the first difference levels. Okay, at the first difference level. So, now x t is integrated of order 1, y t is integrated of order 1. So, let us assume that they are integrated of order 1 only. So, then you can come to next step only. If they are not a mismatch, if there is a mismatch between the order of integration, then easy technique will not help you to detect the cointegration means existence of long run equilibrium relationship. So, what you have to do in the once it is satisfied, then you come down to second step. Second step is to establish the existence of, to establish the linear relationship between the 2 variables. That means, so y t equal to alpha plus beta x t plus u t. Okay. Then or else x t equal to alpha plus beta y t plus u t. Okay. So, there must be linear association between x t and y t. So, so we trust there is a linear relationship between these two, and beta needs to be significant. Okay. So, first condition is that variables must be integrated of order 1, and second condition is that so there must be a linear relationship between these two. Then third conditions, once you have linear relationship, then you will find the error terms. Okay. You will find the estimated error terms. Okay. So, now we have to move to the third condition, that error term should be tesonary in nature. So, the obtained error term must be further tesonary in nature. Okay. So, obtains error term must be tesonary in nature, and for that, so you again apply DF statistics or ADF statistics. Okay. So, that means you see there are 3 conditions altogether. First condition, x t follows 1 1, y t follows 1 1. Okay. Second, x t as a function of y t, or there is a linear relationship between x and y, okay, u t. Let us assume that the linear relationship is here like this, beta should be significant. Then third conditions, you had the u t heads, then fourth head u t head should be stationary in natures, okay. It should be integrated of order 1 or 0, okay. It should be stationary in natures. So, for that you have to apply Dickey-Pollard test or augmented Dickey-Pollard test, okay. So, once you apply Dickey-Pollard test, then the statistic will be like this: delta y t equal to, you can say, mu u t minus 1 plus epsilon t, or this is DF test, okay, Dickey-Pollard test, and or you can apply delta y t equal to mu u t minus 1 plus summation lambda I delta u t minus I equal to 1 to n plus, you can say, b t. This is ADP test. This is ADP test. Okay, this is ADP test. So, now of course, this has to be statistically significant. Okay, this has to be statistically significant, so that it will be stationary in nature. So, that means all these are all, you can say, procedural measures for checking the existence of co-integration between x t and y t, provided x t and y t are integrated of same order, that to here 1 1. Okay. So, that means they are integrated of order 1 only. So, now we will see if there are two variables and we are assuming that both the variables should be integrated of order 1. If not, then what are the problems? So, it will means if there are two variables, so far as the order of integration is concerned, then we may have 4 different situations. So, we may, so not may, there is always 4 different possibilities. Okay. There are 4 different possibilities. Okay. See case 1, the case 1 is, if you see y t is integrated of order 1 and x t is integrated of order 0. Okay. In that case u t will be integrated of order 1, integrated of order 1. Okay. And here x t and y t are not co-integrated, Okay. This is case 1. Case 2, if you know y t integrated of order 1 and x t integrated of order 1, okay, then u t will be integrated of order 0. Okay. So, in that case x t and y t are co-integrated, Okay. Case 3, if y t integrated of 0 order 0 and x t integrated of order 1 1, then u t will be integrated of order 1, okay, integrated of order 1. In that case x t and y t are not co-integrated. Okay. Case 4, okay, case 4, if x t integrated of order 0, okay, and y t integrated of order 0, then u t must be integrated of order 0. Sorry, it is integrated of order 0, of course, integrated of order 0. Okay. Then x t and y t are means co-integration here, that means here there is no such co-integration, there is a co-integration cannot be possible. It is better to write co-integration cannot be possible here. Okay. This is all about the easy test. Okay. So, Engel-Granger test follows 4 different steps. So, that means if there must be two variables in the systems, at least two variables in the systems, and both must have a same order of integrations, and there must be linear relationship between the two, then obtained error term must be stationary in nature, that too by either applying a DF test and ADP test. There is also item called as a CRDW, co-integrating regression or inversion statistics. So, we have discussed autocorrelation problem. So, same thing here. So, we once the order of integrations are same, then we will go for co-integrating equations. So, that means they must have linear relationship. So, in that case when you will estimate that co-integration equation, you will find there will be Darwin-Watson statistic. Again you check the like autocorrelation whether that very particular statistic is statistically significant or not. If it is so, then there is a co-integration, so otherwise it is not a co-integration. So, okay. So, this is how you have to go for this checking the co-integration test. Another advanced test is called as a Johansson and Gichelius test, JJ test. Okay. Basically, this test deals with the two statistics. One is called as a trust statistics, okay. Another is called as a maximum eigenvalue statistics. Okay. This is basically denoted as a lambda trust, okay, which is equal to minus t summations log 1 minus lambda I hat I equal to r plus 1 to n. Okay. Similarly, maximum eigenvalue we will write alpha max equal to minus t log 1 minus lambda hat r plus 1, okay, which is followed by the two equations x t equal to a 0 plus summation a I x t minus I plus epsilon t, okay, I equal to 1 to n. Okay. This can be rewritten as a delta x t is equal to a 0 plus product x t minus p, okay, plus summation I equal to 1 to p minus 1 a I delta x t minus I plus u t. Okay. So, while 1 minus lambda 1 pi 1 minus pi 2 minus pi n, okay, k equal to 1 to up to p and pi equal to 1 minus pi 1 minus pi 2 minus pi n. Okay. So, obviously, this is nothing but alpha plus beta coefficient. Okay. So, this is how these are all derivations. So, I am not going to derive all these details here because it will take lots of time. So, it is not possible to derive all these details with limited lectures. So, what I will suggest you, so for Johansson and Gichelius test, so you have to just pick up two statistics, trust statistic and maximum eigenvalues. So, we have a tabulated value, means we have a critical value. So, with the basis of critical value, you have to compare the calculated value of trust statistics, lambda trust and lambda maximum eigenvalue statistics. Then we like to know it is actually matrix format. So, with the help of it is eigenvalue eigenmatrix. So, it will give you signal how many co-integrating vectors are there, whether there is any co-integrations. That means, if the statistic is significant, it will give you hint that there is a co-integration. So, now how many co-integrations are there depending upon the number of variables involvement, and after suppose there are two variables involvement, then obviously there is only one co-integration equations, two co-integration x t y t y t x t. Similarly, if there are multiple numbers, so you have to find out how many possibilities of co-integrating variables, and accordingly you have to justify what are the number of co-integrations. So, that will give you signal of long run equilibrium relationship between two or more variables. So, that is nothing but you can say cointegration technique. Okay. So, now cointegration will give you the signal whether there is existence of long run equilibrium relationship between two or more variables. So, now once it will give you detection whether the variables are whether there is existence of long run equilibrium relationship between the two variables or more. So, it will not give you the signal of the direction of causality, that means whether all these variables are influencing a single variables or all these variables are interdependent to each other. So, that means you see in the very beginning I have mentioned. So, these three statistics are very integrated to each other, that means unit root problem, cointegration problem and causality problem. So, unit root test will give you signal to go for cointegration, cointegration will give you signals green signal to the causality issue. Ultimately, we like to know what is the direction of causality of this particular problem. Okay. So, now so what we will do here? So, we will discuss the causality problems. Okay. So, now the next problems we highlight is the causality problem. Okay. So, now causality means it will give means long run existence of cointegration only automatically give a signal that there is a causality, but that is not that is essential or necessary condition, but it is not sufficient condition. For sufficient condition you have to go for causality test, and this is how Granger is very famous. So, C.W. Granger has a developed test according to his name, it is known as a GC test. Okay. Granger causality test. So, we have to go for Granger causality test to check whether there is a direction of causality. If it is so, whether it is a one unidirectional causality and or bidirectional causality. That means, there are of course, when we move to cointegration, then the system will be itself multivariate. Okay. It is not univariate like in the case of unit root test. So, moment you are in the cointegration, then the system will be multivariate, then obviously, there is a possibility of causality. Then when there is a possibility of causality, there are three different outcomes you may get. So, there may be no causality between the two or more variables, and there may be unidirectional causality and there may be bidirectional causality. So, let me highlight what is all about this causality issue. For instance, let us start with the x and y. Okay. So, that means, if x causes y, okay, x causes y and y does not cause x, okay, x causes y, y does not x causes. So, this is called as a unidirectional causality. Okay. Unidirectional causality, that means, causality is the three forms: no causality, unidirectional causality, then bidirectional causality. Okay. Bidirectional causality. So, now with two variables x and y, we start with very simple models, then we will go for you can extend to multivariate models. So, like there is a concept called as a vector autoregressive model and vector error correction models. Okay. So, once you will attach with these systems, then we can able to know what is vector error correction model, vector and VAR model, vector autoregressive model. So, second case is y influence x and y influence x and x does not influence y. Okay. This is called also unidirectional causality. This is called as unidirectional causality from y to x. Okay. So, this is unidirectional causality from x to y. Okay. But reverse causality is not there. Okay. So, third case is third case is y causes x and x causes y. Okay. So, this is called as a bidirectional causality. Bidirectional causality. So, that means, y and x both causes each others. Okay. Then fourth possibility is y does not cause x and x does not cause y. Okay. X does not cause y. Okay. So, this is if this is the case, so then there is a called as this interpretation is no causality between y t and x t. Okay. X t or y t. So, that means, for a particular systems having two variables together, so there are three different shapes, in fact 4 different shapes, unidirection no causality, that means if x does not cause y, y does not cause x. Unidirectional causality means x causes y, then x in the other side y does not influence x. Then other unidirectional causality is y causes x, but reverse is not true. Then final is x causes y and y causes x. Okay. So, this is called as a bidirectional causality. So, we have to means cointegration will give you that there is a possibility of causality, but it will not give you the indication of direction of causality. That means, whether there is a really any causality, or if it is so, whether it is a unidirectional problem or it is a bidirectional problem. That is our main agenda of this causality Ganger causality test. Okay. So, now how you have to detect all these things? There is a technical procedure how you have to do all these things. So, let us say start with yt and xt. So, how do you check the Ganger causality test? So, I will directly prepare a model here. So, to check the Ganger causality test. So, we start with the yt equal to alpha 0 plus summation beta I x t minus I equal to 1 to n plus summation gamma j y t minus j equal to 1 to n plus u t. You know, this is one models which you have to use. This is called as a autoregressive models, as I have mentioned earlier. So, the divisions of models may be distributive log models, may be autoregressive log model, but the application of autoregressive model is much higher than the distributive log models. In fact, there is a way how to transfer the distributive log model to autoregressive log model. So, with this particular setups yt and xt, so we need to know whether y causes x or x causes y. So, now in this particular equation, the moment I will write like this way, so it will give you signal. So, here means give you signal, or our aim is to know whether it is x t will influence the y t. Okay. So, it is better we start with here y t, no? That means you start with here y t minus I, then it is x t minus j. Okay. So, that means this particular equation give you signal whether x t influence y t only. Okay. Similarly, we should know whether y t influence x t. So, that means for that we need to have another equations. So, alpha 0 plus summation mu I x t minus I equal to 1 to n, okay, plus summation delta j y t minus j equal to 1 to n plus u t. Okay. So, then this particular equation will give you signal whether y t influence x t. Okay. So, now once this is the case, then our null hypothesis is that these coefficients should, at least one of the coefficients should not be equal to 0. So, that means this parameter should be statistically significant. When this is our task, then obviously this delta j parameter, at least one of the delta j parameter is should not equal to 0. Okay, this is our standard null hypothesis. So, now here we are now targeting to check whether x t influence y t, and here we are targeting to check whether y t influence x t. So, now with two variables in the system, so we have to set two equations. Okay. So, similarly, if there are 3 variables in the system, we will put 3 different variables. Okay. So, 3 different equations. If it is 4 variables in the system, then we will apply 4 different equations. Okay. So, we like to know every time what are the other variables, whether causes other first variable or second variable, third variable or fourth variables. Okay. But when the system involves more and more number of variables, it is very difficult to handle manually. In that case, you have to apply the VAR model, vector autoregressive model. All right. So, now let us assume that with a simple problems y t and x t, means the system should involve only 2 variables y t and x t. So, we like to know how is the procedure to check the causality issue here. All right. So, now the standard procedures, let us we start with y t equal to alpha 0 plus summation alpha I y t minus I equal to 1 to n, okay, plus summation beta j x t minus j x t minus j equal to 1 to n plus u t. Okay. So, let us say this is our equation. So, that means here our agenda is to know whether x t influence y t. Okay. So, altogether there are 3 steps here. Okay. So, like cointegrations, so easy cointegration test. So, it has a 3 different steps. So, first test is step 1 means first step is there are 3 steps. First step step 1 is to have a equation like this y t equal to alpha 0 plus summation alpha I y t minus I. Okay. Purely autoregressive model y t minus I. Okay. Then plus u t. Then you regress all these models, means all these regress these models, then you have residual sum, obtain the residual sum squares RSS, that we will call it RSSR, restricted residual sum squares. Okay. This is called as a restricted residual sum squares, okay. Restricted residuals restricted residual sum squares. Okay. RSS. Okay. So, similarly go to step 2. Okay. So, you fit the equation like this y t equal to alpha 0 plus summation alpha I y t minus I equal to 1 to n plus summation gamma j x t minus j equal to 1 to n plus b t. Then you again have a residual sum squares, that we will call as a unrestricted. Okay. This is called as a unrestricted RSS. Okay. Residual sum squares. So, step 1 is to have residual sum squares, restricted residual sum squares. So, that is nothing but to regress y t with y t minus I only. Okay. So, then obtain the residual sum square and call it a restricted residual sum square. Then second, you regress the full models, then you have the residual sum squares, and that residual sum square you have you name is the unrestricted residual sum squares. Okay. So, now in the step 3, so you integrate this and this. Okay. So, how you have to integrate? For that you have to apply f statistics. So, f statistic is nothing but RSS R minus RSS U R, okay, divided by m whole divided by RSS U R divided by n minus k. M represents here, m represents log length. Okay. Log length, k represents number of parameters in the systems, and n represents sample size. Okay. So, now you get the f statistics here. So, now if f is significant, that means this is calculated value of f, and you have a tabulated value f provided with this degrees of freedom. So, once you find that f is statistically significant, then you will conclude here x t causes y t. Okay. X t causes y t. Again for a reverse causality, you fit the equation similar way, in this for reverse causality you fit the equation x t equal to alpha plus summation beta I x t minus I equal to 1 to n plus summation gamma j y t minus j equal to 1 to n plus b t. Okay. So, again you have to follow the step 1, step 2, step 3. Okay. Step 2, step 1. So, that you will get RSSR, you will get RSSUR, and you will get f statistic, which is a function of RSSR, RSSUR divided followed by log length, sample size, and degrees of freedom. Okay. So, this is how you have to calculate the f statistics. So, now if by any chance it is significant, then you will call as x influence x. Okay. So, now in the first case we have checked x influence y, and here we are checking y influence x. Now you compare here. Okay. So, if it is true, then it is called as a bidirectional causality. If this is true, this is not true, then it is called as a unidirectional causality. This is true, this is not true, then this is called as again unidirectional causality. This is not true, this is not true, then this is called as a no causality. Okay. So, these are the 4 outcomes we have to find in the case of Granger causality. Here one of the standard tricks is that, because before this is simple Granger causality test. So, here one of the standard assumption is that x t should be integrated of order 1, y t should be integrated of order 1s. Okay. X t integrated of order 1s, y t integrated of order 1s. So, this is how we have checked through unit root test. This is how we have checked through unit root test, and similarly next step we know what is the x t and y t relationship cointegrations. Okay. So, then we like to know in the third, this is cointegration technique, then this is in the third we have a Granger causality test, that too whether x t y t are causing each others, both way causing each other or no causality each others. Okay. This is how you have to proceed here for checking the Granger causality test. Okay. So, now Granger causality has some advanced versions also. Okay. So, it has some advanced versions. So, model 2, this is what we have discussed is let us say model 1. Model 1, what is the condition? X t is followed by 1 order of integration 1, and y t is the order of integration 1. Okay. So, then you apply the what we have already discussed, but there may be other forms of model. So, I can write like this way. So, delta y t is equal to alpha 0 plus summation alpha I delta y t minus I, okay, I equal to 1 to n, okay, plus summation beta j delta x t minus j t minus j, okay, j equal to 1 to n plus delta E c t plus u t. Okay. This can be one models, and another models I will calculate delta x t, which is nothing but let us say beta 0 plus summation beta I delta x t minus I equal to 1 to n plus summation mu j delta y t minus j equal to 1 to n plus this I will call it delta 1, this I will call it delta 2 E c 2 E c t plus b t. Okay. So, this is another form of the models. So, this particular structure will give you signal whether x t causes y t. Okay. This will give you signal whether y t causes x t. Okay. And this will give you long run impact, and these are all give you short run impact. Okay. Short run impact. So, that means once you check the unit root component, then obviously it will give you the order of integration. So, by the help of order of integration, you get to know what type of models further you have to use for cointegrations and causality. So, once you have order of integration, it will give you signal of how to check the cointegrations and how to check the causality. So, the moment you will get the variables, means you get the information about the tensionality issue, then obviously you have to enter the cointegration, because it has already given the signal that there may be long run equilibrium relationship, and for that you have to apply a cointegration technique. So, once you apply the cointegration technique, then obviously if it is there, then obviously it will give you the signal to the Granger causality test. Okay. Means existence of causality. So, for that we need to apply the Granger causality test. Then once you apply the Granger causality test, it will give you signal whether whether there is really causality or not. If it is causality, then whether it is unidirectional causality or bidirectional causality or no causality at all. So, this way you have to calculate the entire issue, or you want you can explore how to check the causality issue. The thing is here, you remember here this particular ECT here, ECT stands for error correction terms. Error correction terms here the standard format is the variables are co-integrated, but we are using 10 data. Okay, so that means it is a integrated of order 0. Okay, integrated of order 0. So that data you have to use to justify the causality. That means how to get this ECT, other items are always available. So you have to just apply the first difference and you can get through, but in the case of ECT it is not available directly. So you have to get through it. For instance, how do you get ECT? No, because once the variables are integrated stationarity, then you have to check the co-integration. So for that you need to know whether there is any linear relationship between the two, that is yt as a function of xt, then or xt as a function of yt. So obviously there is error term ut and there is error term ut. Okay, so the moment you will get the error term, so that error terms once you get the error term, that error term will be considered as a error correction term. Again it has to be insert in a particular in a particular equation, then you have to check the impact of ECT on this particular variable at the first difference levels. So if it is so, then obviously so we can get to know whether means here in this particular format. So you have two different objectives. First objective is the direction of causality, and second objective is the short run impact and long run impact. Okay, so some of the it is very essential because it is a time series model altogether. So we have a short run interval and we have the long run intervals. Okay. So now according to this setup, so we can check the structures and you can get to know the results. Okay. So this particular structure we can call it a model 2. Okay. So there is another models, so we can write like this way, model 3. Model 3 is, so I can simply write delta yt equal to alpha plus summation alpha I delta yt minus I. Okay, I equal to 1 to n plus summation beta j delta yt minus j, j equal to 1 to n plus ut. Okay, so this is one equation, and another equation I will call it delta xt equal to alpha plus this is I will call it alpha 1, this is call it alpha 2, then I will call it mu I delta xt minus I. Okay, I equal to 1 to n plus summation you can say alpha beta gamma. Okay, let us put gamma here, then this is yt minus j. So this should be xt minus j. Okay, this is xt minus j, and this is xt minus I, then gamma j yt minus j. Okay, yt minus j, of course delta is here. Okay, delta is here, then j equal to 1 to n plus bt. Okay, this is another models. This is another models where we are using 1 data here, 1 data. So now if this is if in this particular models our aim is to check whether it is x causes y. Okay, it is causes x causes y, and this particular yes, this will give you the signal x causes y, and this will give you signals y causes x. Okay, y causes x. So that means if both are true, then it is called as a bidirectional causality. If only one true, others are not there, so in that case it is called as a unidirectional causality. Either this correct and this not correct, or this not correct, this is correct, it is called as a unidirectional causality. If both are rejected, then it is called as a no causality. Okay, both are rejected, then no, it is question of no causality. Okay, so this is altogether the structure of causality test. So what we have learned in the couple of lectures, So, major issue of time series major problems in the time series modeling is the unit root problem, cointegration problem and causality problem. So, unit roots to give you signal to know the stationarity or order of integration of a particular variables, and that is very important and very much useful, particularly in the financial time series. Then with the help of a unit root test, then we have to move to the cointegration. Cointegration technique will give you signal about the existence of long run or long run relationship between two or more variables. So, once you get to know the existence of long run relationship, then obviously you can able to proceed to check the causality, so direction of causality, okay, because unit root will give you green signal to the cointegration, but it will not give you indication whether there is a long run association. Therefore, as a result you have to go for again cointegration technique like EG test and JJ test, Johansson test. Okay. So, if you get through the cointegration results, that means if there is a possibility of long run association, then it will give you signal that there is a causality, but it will not give you the signal whether it is unidirectional causality or bidirectional causality or no causality at all. Okay. So, in that case you have to go for Granger causality test with the different model setup. With the help of different structure, different setup, you have to pick up a particular form of the model. Then end of the day you have to check whether there is any kind of causality. If there is a causality, then whether it is unidirectional causality or bidirectional causality. Okay. So, with this we can conclude these particular sessions. Have a nice day. Thank you very much.